Hello and welcome to my series Learn Radiology with Dr. Anil Joshi. Today's topic is based on ultrasound physics. To be more specific, is a Doppler physics of a very important effect called as a Doppler effect. Now before going to it, disclosure, acknowledgement and disclaimers. Most of the material we have used in this series is from our department. Going on for many years, we use it for teaching purposes. However, some of it is from the net, which is downloaded after confirming it is royalty free. We acknowledge with thanks from whom we have got this material. Now let's get going to the topic. Today's topic is Doppler effect. One of the most important effect, not only applicable to medical sciences, but also to many other fields, including cosmic field, the speed guns which we see on the road to measure the velocities, in submarines and also in astronomical purposes. Now let's get going to the topic to know what is a Doppler effect. Now first introduction. Everything is incomplete without Doppler effect. Very interesting. From moving vehicle to the space galaxy. How we came to know the world is expanding is because of the Doppler shift in the color waves. Now all this is covered, that is the non-medical aspects of the Doppler in my some other lecture series. Do visit it and do enjoy the applications of Doppler in it. If submarines are lost into the sea, there is also only principle to find submarine is the Doppler. According to the Encyclopedia Britannica, the Doppler effect is defined as the apparent distance between the frequencies at which sound or light waves leave a source and that at which they reach an observer, caused by relative motion of the observer and the wave source. Now here what is important? There has to be movement in either a source or a observer. If both are moving also, there can be Doppler effect. One is moving also, there can be Doppler effect. But if none of them are moving, there is no Doppler effect. Where we see every day, when an ambulance passes with a siren bell ring, the pitch of the siren will change as it approaches closer and as it goes away from us. This shows how the motion of a source affects the frequency experienced by the stationary observer. Here the ambulance is mobile, however the observer is stationary. So here he experiences change in frequency. A similar change is observed in frequency that occurs if the source is still and the observer is moving towards or away. There will be a different shift by which he can know whether the source is moving towards him or away from it. Now Doppler effect includes that any relative motion between the two will cause a Doppler shift effect in the frequency that will be observed. The pitch of the sound wave depends on the frequency of the sound wave. Therefore, a high frequency will correspond to a high pitch and the siren produces waves of constant frequency. What is the important thing? Though ambulance siren is producing sound waves of same frequency, consistent frequency, the observer is hearing it at a different frequencies, sometime with high and sometime with the low. This is a Doppler effect. As it approaches us, the observed frequency increases and our ear will hear a higher pitch. The pitch of the siren will be higher. The change in a siren or change in the common physical demonstration of the Doppler effect is like this. The Doppler effect describes the changes in the observed frequency of a wave when there is relative motion between the source and the observer. It was first proposed in 1842 by Austrian scientist or physicist called Christian Doppler. The effect is that's why known by his name as a Doppler effect. That is, when a source emits waves of steady frequency, if the source remains stationary, the waves it produces will be perceived as being regular or steady. So, they will be steady if the source is steady, both the observer and source are steady, the waves received will be of same frequency. Otherwise, steady by an observer who is also stationary regardless of the distance between the two. If the distance is more or less is not important, but if the distance is changing, it is important, whether closer or longer. However, if either the observer or the source is moving while other remains stationary, the observer will receive a change in the wave or change in the frequency, the sound will be different. The wave frequency is perceived as higher when the distance between the two is shorter and longer or lower when the distance is longer. This phenomenon is called as Doppler effect. Now, we have seen in detail shortly or in a very simple way Doppler effect. However, let me explain it to you again. Let me explain you Doppler effect again. Following are the few basic features of the wave motion. Wave comes in a variety of forms, that is ripples on the surface of pond, or sound with a siren banging, or a light, that is the galaxies moving, and the earthquake tremors all exhibit periodic wave motion in serial manner. Now, here we are seeing a waveform. There are two things, one thing is upstroke and downstroke. Now, wavelength and frequency, let us try to understand what it is. Wavelength and frequency are used to describe all types of waves and motions. Now, wave has got a crest, that is an upward peak, and a lowest peak or lowest portion, that is called as trough. The wavelength is the distance between two consecutive peaks. So, what we see in a wavelength is the crest, that is the upward peak, then is the trough, which is the lowermost portion, and there is the distance between two consecutive symmetrical points, that is the wavelength. So, these three things are important when we are understanding a Doppler effect. And the frequency is the count of number of peaks that passes a reference point in a given time. Now, let me describe it to you in a diagrammatic way. We are having diagrams by which I will show you. Now, here what we are saying, the vehicle is moving. Now, first the vehicle is stationary. Neither the vehicle is moving nor the observer is moving. So, you are getting a stationary frequency. Got it? You get a stationary frequency. Now, suppose the observer is standing at same point. Observer is standing at the same point, but the vehicle or ambulance is moving away from him. So, what will happen? It will produce sound waves of two frequencies, a lower frequency and a higher frequency, and that is how he will appreciate it, change in the sound or change in the Doppler waves. So, this is a very simple way to explain to you. Now, this is the concentric, like we see in earthquake or when a stone is dropped into water, there is a stationary source and the concentric waveform are generated. They do not cause any Doppler shift, no Doppler effect is seen, and there is no change in the frequency. Now, here again we are describing same, that wavelength and direction of the wave propagation. Now, here it is, there is no Doppler effect because there is no change in movement or position of the observer and the source. Now, here see, now the source is moving, it will be producing change in the wavelength. You are seeing those with the short wavelength and those with the long wavelengths. The waveform changes as the source is moving. So, this will explain to you in very easy way how a Doppler effect is. Now, that is why we are coming to a conclusion. The Doppler effect finds its application in many places including movement of the stars. However, we will concentrate on the medical applications in this lecture and in some lecture. However, there are lectures which describe you or which tells you about the other application. It is applied in weather observations, then characteristic cloud movement and weather patterns. It has other application in aviation and radiology also. It is even used in a police to detect the speed. If any vehicle is exceeding the speed, they can know it, where the speed gun is stationary and it takes a momentary reading of the vehicle, but that change in that time also the machine will know speed of that vehicle and whether it is exceeding the speed limit or not, which are now these are the essential in the small radar units like we are using it in a speed gun. Our understanding of Doppler effect has allowed us to learn more that the universe is a part of, we are part of universe and this universe is expanding. This also we came to know because of the light Doppler effect that is also covered in some other lecture. For light waves, a frequency determines the color. We see the highest frequencies of the light are the blue, and the visible spectrum of the lowest frequency is a red, that is called as red end point of the spectrum. If stars and galaxies are traveling away from us, the apparent frequency of the light may emit decrease and their color will move towards red end, that is the red effect. This is known as red effect or red shifting, that will know where the galaxies are moving away. A star travel towards us will appear blue shifted, that is of high frequency. This phenomenon allowed Edwin Hubble in 1929 to propose that the universe was expanding when he observed that all the galaxies appear to be red shifted, that is moving away from us and also away from each other. With that, we are coming to an end of a Doppler principle, made it in a simplified way and interesting way with illustrations of different ways. I hope you have enjoyed the lecture. If you like the lecture, if you are happy with the information, tell your friends, give us a like and subscribe our channel. Thank you, goodbye and good luck.